how do we find the solubility products of different compounds that have this kind of molecular formula, AB, AB2, AB3, A2B3? When we say AB molecules, these AB molecules, when we say AB molecules, talking about sodium chloride, potassium chloride, and let's say silver chloride. Okay, these are all AB molecules. Okay, they are all AB molecules. For AB2 molecules, we are talking about molecules like magnesium chloride, calcium fluoride, also calcium fluoride. There are so many of them. Okay, when we talk about AB3 molecules, AB3, we are referring to, let's say, aluminium chloride, something like this. We also have borohydride, something like this. These are all AB3 molecules. Okay. Also, we have compounds like Ag2CO3. These are also AB3 molecules. Okay. So there are so many of them. You can also write. So the next one we also have. Let's say the next one is A2B3. We have molecules like bismuth sulfide, something like this. So when we have molecules like this, that's what we are talking about. Okay. So now, how do we generate their equilibrium, their solubility products? Let's start with AB. For AB molecules, these molecules will dissociate into A plus B minus, right? So the KSP for this is going to be A plus multiplied by B minus. Okay? So taking this thing to be their solubility, we have that KSP is equal to X to the power of 1. Why is it to the power of 1? Because the coefficient here is 1. Multiplied by X to the power of what? 1. So if you simplify this, KSP for this is what? X squared. Where X is solubility, right? So KSP is equal to solubility squared. Solubility squared. So this is the equation to calculate KSP for AB molecules. So take note of this equation. Take note of it. Take note of it. It works for AB molecules that have this kind of shape. Okay? Then let's look at AB2. AB2 molecules. Okay? For AB2 molecules, they will ionize to A plus 2B minus. Why did I put 2 here? This 2 is because of this 2, balancing the equation. Okay? So AB2 ionize to this. So if you ionize to that, we have that KSP is equal to this A plus multiplied by 2B minus, like this. Okay, raised to the power of what? 2 also. Okay, raised to the power of 2. Are you following? So why is it raised to the power of 2? This 2 that is also here, and we have the 2 inside here too. So for the KSP will be equal to this. It's like saying X to the power of 1, right? Multiplied by 2x to the power of what? 2. So take the B as X, take this 2 as 2. So 2 times X. So if you open this, we have KSP is equal to X multiplied by, this will give you 4x squared. This times this will end up to what? 4x cubed. So where X is solubility, so KSP is equal to 4 into solubility all to the power of 3. So you can use this expression to evaluate anything you are looking for. So if you make the solubility subject of formula, you are going to get the KSP. Okay? So if you make this KSP, let's say for example, let's say that we make let's make solubility subject of formula. Solubility will become the cube root of KSP all over 4. So this is how we relate this and this. Okay, so we can use this for this kind of system, this kind of molecules that will give us AB2, okay, or 3 moles. We can say this is total of 3 moles produced. Take note, total of 3 moles produced here, but this one produces what? 2 moles. Why is it 2 moles? Because I have 1 mole, but this one gives us 3 moles. Okay, so we are going to do for the second, for this one, and then for this one. So you can know the several formulas you are going to use to evaluate this KSP. So remember, we have done for this molecule. Remember that we have done for the AB molecule, and the AB2. Okay, so for the AB3 molecules or compounds, we have that AB3 will dissociate into A plus 3B minus. Remember that this 3 is to balance this guy. Okay, so for this kind of molecule, we know that the KSP is equal to concentration of this A plus multiplied by 3B minus to the power of what? 3. Why is it to the power of 3? This 3 that is here, right? So KSP is equal to, this is the solubility, the ions have the same solubility, so it's going to be x to the power of 1 multiplied by 3x to the power of what? 3. So KSP is equal to, we have x multiplied by, this will give us 3 times 3 times 3 is 27, right? X cubed. So multiply this thing, we have 27x to the power of 4. Is that not so? So KSP is equal to 27 into solubility, where x is solubility, right? To the power of 4. So that if I'm now looking for solubilities only from here, the solubility becomes the 4th root of KSP all over what? 27. So this formula I'm giving you are important. Just take note of the formulas, okay? You must not know how to derive it. Just take note of the formula because you're going to use them in calculation. So the formulas are the most important thing you need to know. Okay? If you don't know what I'm doing here, just look at it once more and note this, and note when it's appearing for compounds like this. Now the next one we're going to have is, we have let's say we have an A2B3 molecule. Okay, this one is rare. You hardly see this one in your calculation, but it's rare. But let's look at it. Okay, so for this we have A3 goes to this person, we have 3 plus, 2 goes to this person, we have plus, B2 minus. So balance the equation. Here is 2, so I'm going to put 2 here. Here is 3, I'll put 3 here. So the KSP for this is going to be equal to 2A plus to the power of 2 multiplied by 3B minus to the power of what? 3. So that KSP is equal to, this will give us 2x to the power of 2 multiplied by 3x to the power of what? 3. Okay? So KSP is equal to this. 2 times 2 is what? 4. X times x is what? X squared. So I have 4x squared. So if you expand this, you have 4x squared. Okay? If you expand this one, 3 times 3 times 3 is 27. Okay? X times x times x is x to the power of 3. Okay? So KSP is equal to, this times this will give you 108. If I'm not mistaken. Yes. 108. Yes. 4 times 27. 7 times 4 is 28. Okay. Yeah, 108. X squared times x to the power of 3 is x to the power of 4. 5. Okay. So we have x solubility. So KSP is equal to 108 into solubility to the power of what? 5. Okay. So making solubility subject. Solubility subject of formula becomes the 5th root of KSP all over what? All over 108. So the formulas you are seeing here, very important. So let me circle the formulas. Okay? So these are the formulas you need to take note of. So we're going to look at some calculations that we can be able to apply these things to get the solubility product and also the solubility depending on the calculation we are trying to solve.